We have already completed our combinational circuits. Now I will upload series of presentations involving different problems in combinational circuits. I will do the same for our sequential circuits also when we are done with it, and this is very helpful for you to understand the course and also revise the different topics that you have studied. I will take different examples from the competitive exams, and all the examples are very good. It will cover a very vast topics and it will help you to understand key concepts and also the implementation of the theory that you have already learnt. Now before actually going to the question number 1, I will explain you few things about this series of presentations. Every part like this one, this is the part 1 for the practice problems on combinational circuits, will have 2 problems. Okay, and each problem is selected very carefully so that you are having a greater understanding of different topics. So let's move to our question number 1. In this you can see a circuit on the right hand side of your screen, and we have to find out what is the value of S, the Boolean expression for S, and then we have to check from our options that which one is not S. So what will be our steps to solve this problem? You can see there is a 4:1 marks. So the first thing that we have to do is to do the analysis of this multiplexer, and I will say this is the output of my multiplexer and its name is Y. So our first step is to find out the value of Y, then we can simply find out the value for your S. So let's do it. You can see that the selector variables are AB, if this is S0, S1, and the selector variable plays a very important role in the determination of the output. So we will make the truth table. S1, S0 are the two selector variables for 4x1 marks, and S1 in this case is A and S0 is in this case is B. The output is Y. Now for combinations, let me write it down quickly. Now your Y is simply I0, I1, I2, I3. You know how the multiplexer works. When it is 0 0, the I0 will be linked to your output, 0 1 I1 is linked, 1 0 I2 is linked, and 1 1 I3 is linked. Now we have to find out the Boolean expression for Y. So Y is equal to A complement B complement I0 from the first combination, or A complement B I1 from the second combination, or A B complement I2 A B I3. Now you can see from the problem that the values of I0, I1, I2 and I3 is already been mentioned. I0 and I3 are 0 and I1 and I2 are having the value equal to 1. So I will replace them. I0 is now 0, I1 is 1, I2 is also 1, and I3 is 0. So Y is equal to A complement B or AB complement. As it is 0 and the AND operation with 0 gives us 0, that's why I have neglected the first and the last minterm. Similarly, the AND operation with 1 gives us the same entity, therefore I am having A complement B or AB complement. Now if you remember from the logic gates, the A complement B or AB complement is equal to A XOR B simply. So this is the value of Y, and now we can find out the value of S. So S is Y XOR 1, and I can open it like Y complement 1 complement or Y and 1. Now you can see that 1 complement gives us 0 and the AND operation with 0 is 0. So 0 or Y, and it is equal to Y. So this S is equal to Y and Y is A XOR B. So S is simply A XOR B, or I can write it as A complement B or B complement A. So this is what we have to find out in this problem. Now the important thing comes in which we have to check for our answer from these different options. Now if I talk about the XOR combination, then it is odd ones detector. So if I say this is my min term M0, M1, M2, M3, and y is equal to s, that's why 0 1 1 0 is the value for our s. And if I write s in terms of min term, then it comes as summation m, this is m1 m2, so 1 2. And if I write it in terms of max term, then pi 0 3. I will write min terms for which s is 0, that's why m0 m3 is here. So this is what we have in terms of min terms and max term. So the option A is definitely representing our s. Option B is also representing our s, XOR gate with AB as input, and option C is also representing our s. That's why A, B, C are correct, then definitely D is wrong. And also you can see that A complement B complement, or AB, is equal to A XNOR B, which is definitely not equal to our s. So D is the answer of this question, and it is all you have to do in this problem. Now let's move to our example number 2. And in this also there is a mux involved, and this time it is 8:1 mux, and you have to find out the function x. Here this is x, and definitely the function x is having the variables a, b, c, d, the 3 selector variables, and d as the input. Now you have to find out the value of x. That you can do very easily. When there are 3 selector variables, we are having 8 possible combinations. So let's make them quickly. Zero one 0 1 0 1 0 1. Okay, and the output is x. So the input is simply I0, I1, I2, I3, I4, I5, I6, and I7. Now we have to find out the Boolean expression for x. So x is equal to A complement B complement C complement I0. I will write it down very quickly. You can also do it by yourself. A complement B C complement I2, A complement B C I3, A B complement C complement I4, A B complement C I5, A B C complement I6, A B C I7. Now the only thing that we need to do is to put the values of I0, I1, I2, I3, I4, I5, I6, and I7 from the question like we did in the last problem. So I0 is 0, you can see from here, you can see it is 0. So this will be 0. I1, you can see, is equal to D. So I'm having A complement B complement C D, and I2 is also equal to 0, so this will be 0. I3 is 0. I4 is 1, you can see I4 is 1, so I will write it this is A B complement C complement, or I5 is D complement, so A B complement C D complement, or I6 is 0 and I7 is 0, so the last two min terms are also 0. Now let's see what we got. We got A complement B complement C D, A B complement C complement, A B complement C D complement. So if I am having 4 variables, then there are 16 possibilities, and we have to write down the min terms and max terms depending upon that 4 variables. So let's try to find it out without writing the truth table. Let's see how to do it. A complement means 0, B complement means 0, C is 1, D is 1. And what number is this? 0 0 1 1. It is 3, of course. So if I write in terms of min terms, I'm having 3. A B complement C complement. This is minimal form of the minterm, so we have to make it canonical. D is not present, so definitely it was like A B complement C complement and D or D complement. That's why D became 1. So I can open it and I'm having A B complement C complement D or A B complement C complement D complement. We expanded it and make it canonical, writing it in the form that we got from the truth table. So I'm having A B complement C complement D. It means 1 0 0 1, and this is what? 8 plus 1 is 9. So 9 is also my minterm. And A B complement C complement D, it means 1 0 0 0, it means 8. And A B complement C D complement, it means 1 0 1 0. This is definitely 8 plus 2, my 10. So in terms of min terms, I'm having 3 9 8 10. So definitely option A is correct, 3 9 8 10. And when there is 3 9 8 10, the remaining thing, it means 0 1 2 4 5 6 7 11 12 13 15 is my max term. So option C is correct, because you can see in this 10 is involved and 10 is my min term, so it can't be my max term. So option A and C is the correct answer for this problem. I hope you got it. So please feel free to comment your views about this initiative that I have taken to let you practice the different problems involved in the topic, so that you are having a better grip on this subject. After all, I want you to score maximum in the digital electronics. So please feel free to post the feedback. This is all for this presentation. See you in the next one.